Let's look at how to add two vectors. Given two vectors x and y of size n, their sum is computed by adding corresponding components. What is more interesting is to look at what this means geometrically. Let's say that we have two vectors x and y. Recall that vectors have a direction and a length, but you can move them around. Now, take vector y and move it so that its tail is where the head of x is. We will call this laying the vectors head to tail. The vector that results from adding the vectors is the vector that starts at the tail of x and finishes at the head of y. So, in other words, it is the net result of following first vector x and then following vector y. Now, if you simply execute the algorithm for summing the two vectors, you sum their components, and indeed you get the vector with components that equal those of the resulting black vector. You could have instead laid the vector x head to tail with vector y. If you then first follow vector y and then vector x, you find that for this example, x plus y is equal to y plus x. In one of the homework exercises, you will be asked to determine if it is always the case that x plus y is equal to y plus x. In other words, that vector addition is commutative. To summarize, when talking about adding two vectors, you may want to keep this picture in mind.